So in this video, we're going to review kind of the second module or the second homework, which was about aggregate planning, variability, and kind of coordination in the supply chain. And so when we think about these, we're really thinking about how can we acquire resources and how many resources do we need? And that's really aggregate planning. So as a reminder of like, why do we need aggregate planning? Is that capacity decisions need to be planned before demand is known. And there's usually some lead time and cost in getting our needed capacity. And so if you remember back to aggregate planning models, we're typically planning 3 to 18 months in advance, and we need to understand we have an input of demand. So demand forecast is now an input, not a decision variable. But we need to meet this demand, and we need to think about how should we meet this demand. Should we meet that demand by having the proper labor, raw materials? Should we inventory? Should we outsource? Should we have overtime? And so that's what aggregate planning does. And so if you think about that as more like a formal optimization problem, what are we given? We're given the demand forecast for each period in the planning horizon. And then what do we get to determine? We get to determine how should I meet that demand, and typically why these problems are hard. If the answer was demand was always flat, you wouldn't need an optimization model. You would just say, okay, I'm going to do this. It's very obvious, it's simple. But the problem is demand is typically not flat. It changes over periods. And so we need to think about how should I best set up my resources so that I can meet this demand, but this demand that changes over time. And so you can think about, we could change production levels, we could outsource some things, we could have build up inventory if that's allowed. And so those are the things we're determining in our aggregate planning model. And we determine that by usually minimizing some costs or maximizing some profit over the planning horizon. And that typically requires quite a bit of input data to do that. And so the answer of, should I change my production, meaning I'm hiring and firing people, or I'm using overtime versus building up inventory versus outsourcing, that really matters based on the types of input data that you have in your model. So you should be able to understand what is an aggregate planning problem. You should be able to formulate an aggregate planning problem. This will mainly show up in the conceptual portion of the final exam, but I could ask you, for example, a multiple choice, true or false essay question, like which of these constraints models this aspect of the problem, etc. So you should be able to do that. You should also understand the components of an optimization model. I think most people do, but just remember decision variables are what you get to change. So in an aggregate planning problem, that is, how much do I produce each month? How much inventory do I have at the end of each month? What's our labor force, etc. So these are the decision variables that once you hit Excel Solver to go solve, that's the values they give you. Parameters are the pieces of data in our model, and there's lots of them, and this influences what is optimal. And how do we determine what is optimal is our objective function, which is telling you what is good or bad. And so usually we're maximizing profit or minimizing some sort of cost, and we are going to set the decision variables in a way that maximizes or minimizes that function. And then constraints are what restricts us to do something. So in the aggregate planning problems, this is the idea that you shouldn't get 0, 0, 0, 0, right? If it says to do nothing, then you don't have the constraints, right? So a typical constraint in the aggregate planning problems is that we should meet demand. And so we have a constraint that says we must meet demand each period, and that forces us for our decision variables to get off of 0. All right, so you should be able to do that. You also should be able to understand these different ways of buffering. And so if you think about aggregate planning, really aggregate planning are all different ways of buffering against variability and expected demand. So at the end, you have an answer where you say you use some inventory, maybe you have some extra capacity. So if you think about your Excel Solver sheets, your constraints have, the right-hand side is your capacity, and the left-hand side would be like your production each month. If those aren't exactly equal in your optimal solution, then you're using capacity as a buffer. If you're not meeting some of the demand, so you're saying I'm going to backlog some of my demand, that would be time. And then we didn't explicitly really study the money aspect inside of aggregate planning, but you should understand what that is. And so in terms of the final exam, there will be questions that will say, in this situation, what does this mean in terms of buffering? And so you should understand the differences between all of those different things. And so, okay, on the final exam, you should identify the appropriate types of buffers, inventory time, capacity, and money that can be used to manage variability in different scenarios and what they represent. You should know the purpose of each of these components of an optimization model. I just went through that on a slide. You should be able to formulate an aggregate planning model as a linear program. So again, most of this will show up on conceptual parts of the exam. And so I probably won't have you formulate the full model and implement it in Excel Solver, but you are responsible if I gave you like some data inputs and you could pick what is the correct optimization, let's say, constraint. So you should be able to do that. So I think it would be good for you to review that before you do the conceptual part of the exam. And then solve the optimization models and understand what they mean. And again, in the conceptual part, I'm not asking you to solve an actual model using Excel Solver, but you should, if I gave you maybe outputs of the model, you should know what they mean. You should be able to tell me, here is maybe the output. What does that mean in terms of how am I buffering against all these changes in demand variability? And then we had another lecture all about variability and why variability is bad. And I think if you need an example of why variability is bad, COVID is a great one, okay? And so you should understand the impact of variability on operations. And the biggest thing is, even if you have the same mean expected value, if you have more variability, our jobs as operational managers, as supply chain managers, gets harder. What that means is we either need to have more resources, which is more expensive for the same service level, or we have the same level of resources. So let's just take inventory or capacity, any of these buffers, but then we're not going to have as good of customer service. And so variability is really bad. And we are seeing that in a lot of the things going on in COVID right now. So you should understand the relationship between variability, resource utilization, waiting time, and congestion. And I have a couple slides after this to explain that and remind you about that. You should make and justify resource planning recommendations based on average requirements and variable processes. So the key thing here is that your average release rate has to be strictly less than your capacity if you have any variability in your process. So you cannot have 100% utilization of your resources if there's any variability in your process. Otherwise, it'll blow up. The system will blow up and you'll have infinite waiting times, or you'll lose people. So that's an example of incorporating variability into decision-making processes. If you're gonna go buy any resources or set up the labor, don't assume 100% utilization, because all processes have some level of variability. You should be able to identify which processes have lower variability versus which ones have high, and then identify ways to reduce some variability. So there's more information on some slides that are coming up. Here is one of the relationships between release time rates. You could also think about this as utilization. So utilization of 100% versus cycle time, and cycle time is the time in the system. So if you notice here, if there's any variability in the system, if I release things at 100% utilization, my time in the system is infinite, or you have an infinite line in steady state. Typically, you don't see this in practice, because what happens is people bulk. They say, I'm not willing to continue to support your business. I'm just not gonna be there. So that's one relationship. The other relationship you should be aware of is that these lines are highly nonlinear. And so at the utilization low levels, these are relatively flat. And then at some point, it hits this really nonlinear relationship. And so these nonlinear relationships is why there's a rule of thumb that you should use approximately 80% utilization to set resources. And that's because that approximately 80% is before this crazy, really fast increase happens. If I'm over here at 90%, we're now having much worse performance. That does vary based on, what is your variability levels, what is the cost of waiting versus cost of resources, etc. So that's why 80% is a rule of thumb, but you should understand that. And then the other thing you should understand is that if you have lower variability, you are able to do better than if you have higher variability. And so what does that mean? If you say, okay, I want an average cycle time of at most 4 hours, if I have high variability, I have to have a 70% utilization of my resources. But if I have lower variability, I can get almost to 90%. And so 90% utilization is better from a cost perspective, and you have the same service level. So lower variability gets you either better service level for the same resources, or or you get better service level. Yeah, so lower variability is good. So lower variability means for the same utilization of your resources, you get better cycle times, so smaller cycle times, or the reverse. And so you should understand that relationship. You should also understand that you should never release things at full capacity if there's variability in the system. And then this is just what, I guess, repeating what I just said, is lower variability. You can have higher resource utilizations. Higher variability in systems requires lower resource utilization for the same level of service. And so service is the waiting time you could think as a measure of service. All right, so what can you do to reduce variability? A lot of the things you can do to reduce variability are things that are just industrial engineering principles, like training employees, improving quality, having standard operating policies. Those are things you're learning hopefully in your other courses. Things you can do in terms of more supply chain specific things is we studied in the inventory chapters about pooling of resources. So if we have centralized pooling of inventory, we have less safety stock than if we had decentralized, or each region had their own inventory. That's true for inventory and safety stock. That's also true for other types of capacities. And so the idea that you would have one central pool of resources versus a bunch of separate ones can really help reduce variability immensely. And you can think about that as well as the homework problem where you need to make an Excel sheet with different machines. If you have one big workstation that has 10 little machines all together centralized, that has lower variability than if you have each one of them working separately. Okay, so that's a way to reduce variability. Another one that's kind of more supply chain focused is if you can do a better job forecasting your demand, then you have less changes between what we expected and what actually happened, which is a version of reducing variability. We can also think about coordination, reducing the bullwhip effect. So letting people be aware of what's going on, and that helps from a more systematic or holistic supply chain perspective. And preventative maintenance is another one, because if you're basically, remember from the machine, if it's down small little instances versus one really big one, that has less variability. And so preventative maintenance is a way to do that. And so another kind of reminder is we first studied variability and then we studied inventory. And so I think a way to think about connecting these topics is when you think about calculating safety stock, this is really an example of how variability impacts buffering. And so here we're doing inventory as our buffer, but you can think about this a little bit more general, is that as your standard deviation of lead time demand, that's variability goes up, your safety stock goes up, right? And so this is an example of how we quantified that later on in the class. And I would like you to think about bringing that topics back into variability and hopefully allowing you to think through that. And then the last kind of comment about this topic is to remember what the bullwhip effect is, which is the idea that if you're close to the customer, you usually have better information, and therefore you have less variability of the orders placed. And as you go further and further away, so you get further and further away from the customer, what happens is you get these big swings in how much you order, and that tends to propagate up the supply chain.